Hello, my name is Clemens. I'm the CTO of Percival, and today we're going to look at another sensor effect, namely velocities, radial velocities. In my last couple of videos, I showed you how to use the ASAM OpenX standards, how to build up a sensor simulation using the Percival Sensor Model Development Library, the SMDL. And in my last video, I went a little bit into detail of certain class of effects, the timing effects. So I showed you the motion scan effect, changing beam patterns. And today we're going to look at a very specific class of LiDAR sensors, and that's FMCW LiDARs. And the big thing about FMCW LiDARs is they can measure radial velocity for every individual detection. So every individual point of a point cloud has a radial velocity measurement, and that's measured using the Doppler effect. And of course, if you have an FMCW LiDAR, you want to simulate that, and then you also want to simulate that effect. And let me show you a very similar example to the last ones. Just in this case, we have a generic FMCW LiDAR on the top here. Here you can still see the intensities, so that's what we had in the also in the last examples, intensity measurement. But here in SimSpectre, you can actually change or select the color channel. So you can select how the point cloud should be colored in this visualization. It's now set to intensity. But we can also set this to relative radial velocity. And you already see here, now you have different color values. Blue in the front, red in the back here. And now you can see if we select a point, let's actually start with the ones here, screen color here. And you will see that the relative radial velocity is at 0. Of course, because the sensor is moving with the car, so every detection you have on the car will have a relative radial velocity of 0. On the front here, you have a positive radial velocity of around 20 meters per second. And here in the back, let me select one point here, you will have the opposite, so negative around 20 meters per second. And that's very close to the ego velocity. If I go here and select the ego vehicle, you will see the velocity here, and that's actually 22 meters per second. There's a little bit of a deviation because we're not going straight in front, so slightly angled down, so the radial velocity component is a little bit less, but you can see that here. And if I have a different car going by, like this one, I can also go here and see the radial velocity. It's close to the ego vehicle speed, a little bit faster. So it's going further away. And you can see that here with this negative radial velocity. So for every point in the point cloud, for every ray that the ray tracer gives you as a result after the ray tracing, you can get a radial velocity value. And you can, of course, use that for FMCW LiDAR. It also gets utilized in radar simulation, where, of course, you also have the Doppler measurement. You can get that for every individual point here in the point cloud. And if we go around a little bit, you also see that we can what's sometimes referred to as Micro-Doppler. So you not only have one velocity measurement of a whole object, but you get the micro movements. In this case here, you have the wheel. If I go a little bit to the side here, you can see the points here. So you have a different velocity at the bottom of the wheel than at the top of the wheel, because of course it's rotating, so it has different velocity components. And that's also something that the SMDL is capable of. So every element of a moving object that has their own velocities is factored in here, and you can get accurate relative velocity readings of those elements. This is not only true for rigid bodies that move, but also for humans, for example. Let me open up another trace file, and we have this human demo here of where we have, to make this a bit smaller again, we have this human here. In the first time step, everything is standing still. But if we go to the next time step, you will see on the human, because its arms and legs are moving, you can see different velocity components. And if we play that back, you see that they are changing. The color scale here in SMDL, in the SimSpectre, is set to the minimum and maximum of that individual's scan. That's why you see this flickering here. But I can actually set this to some fixed values, so we don't have that flickering anymore. And you can see this human, of course it's not moving, it's doing kind of a moonwalk just to demonstrate this here. But you see very nicely the changing points on the arms and legs and the velocity reading of individual points on that changing mesh throughout the simulation. So this is also part of the sensor model development library. You don't have to take care of any of this, it's just automatically in there. And based on the open simulation interface ground truth input, where we get the individual bone orientations and also the orientation rates of a human, and we get the rotation rates of wheels on a car, we can calculate this in the SMDL, all done automatically, and you just get a very accurate radial velocity reading on every individual point here in the point cloud of every individual hit point during the ray tracing. That's it for today. That's it for velocity simulation using the SMDL. Thank you for watching, and see you next time.